Okay, students, good morning and welcome back to our physics lecture class 11 science. Okay, so yesterday we started with dimensions, we did the basics of dimensions. So today let's do some problems of dimensions and after that we'll do applications of dimensional analysis. So here comes the first question, that is find the dimensions of energy per unit volume. Find the dimensions of energy per unit volume. Now, let it be a variable x. Let it be a variable x which is related as energy per unit volume. Okay, energy per unit volume. And I need to find the dimensions of x. I need to find the dimensions of x. Chalo, let's go forward. What will be the dimensions of energy? What would be the dimensions of energy? We need to find out. Now, yesterday we did that energy has same dimensions as that of work done. Has the same dimensions as that of work done. As well as we also read that all the family members, they have the same dimensions. So one of the family members of energy is kinetic energy, which is given as half into mass multiplied by velocity square. Perfect. So let's first of all find the dimensions of kinetic energy, which would be the same for energy. So this goes half constant, won't have any particular dimension. Mass is kg into velocity square, that is meters per second whole square. So what will I get? I get kg meter square per second square. So what will be the dimensions? Dimensions will be n kg mass power 1 meters length power 2 second square. It will be seconds minus 2. So that is time. So ma 2 t minus 2. This will be the dimensions of energy. But what we require? We require energy per unit volume. We require energy per unit volume. So let's find the dimensions of volume also. Volume, the dimensions are very easy. The dimensions of volume are, or its unit is meter cube. Its unit is meter cube. So I can simply state it as cube of length cube. Quite clear? Quite clear? So let's come on to the dimensions of x. So dimensions of x would be energy per unit volume. That is m L2 T minus 2 divided by L power 3. Perfect? Now if L power 3 will go up, it will be L power minus 3. So L power 2, L power minus 3, it goes L power minus 1. It goes L power minus 1. So what I get? I get the dimensions as ML minus 1 T minus 2. ML minus 1 T minus 2. Is it clear to all the students? Please text your response. It's clear so that we can do one more problem. Please hurry up and text me. Is it clear to all of you? Okay, chalo. Let's go ahead with another question, and now this time it's your turn. I'll just help you at the last. Okay, this question is done. Find the dimensions of angular momentum. Find the dimensions of angular momentum L. Find the dimensions of angular momentum L, where where L is given as mvr, where M represents mass, V represents velocity, and R represents the distance. Okay, or the radius. Okay, so L angular momentum is mvr. Quick and please find out the dimensions of angular momentum. Please be quick. Chalo, quick. I want the answers very quick. See, these are very simple problems. It should not take so much of time. We've got an answer ml2t minus 1. Chalo. Next, please. Others also come up with the answer. Come up with the answer. So most of you are having ml2t minus 1. Chalo. Let's check if it is ml2t minus 1. Okay. Now L is mvr. So the dimension of L will be mass into velocity into r, that is radius. Okay, so radius can be treated as the length. So mass is kgs, this is meters per second, and this is meters. So I'll be having the dimensions as m L2 t minus 1. Perfect. So yes, everybody's got the right answer, that is m L2 t minus 1. Clear? Okay, chalo. Find out the dimensions of R. Find out the dimensions of R in the gas equation, in the ideal gas equation, that is PV is equals to nRT. PV is equals to nRT. P is the pressure, V is the volume, N is the number of moles, R is the gas constant, and T is the temperature. You need to find out the dimensions of R. Chalo, go ahead please. Hurry up. From this equation PV equals to nRT, first of all we get the relation or expression for R. So the expression for R from here, I will be getting as PV by NT. PV by small nt. Please check. R would be PV by NT. Now I need the dimensions for pressure. Volume, NT, they are direct. So I need the dimension for pressure and volume. So what is pressure? Pressure is force acting per unit area. Perfect. What is force? Mass into acceleration. So mass into acceleration upon area. So what will be the units? Kg. For acceleration it is meters per second square, and for area it is meters square. So what will be the dimensions that I'll get for pressure? For pressure I'll get the dimensions as ml minus 1 t minus 2. We'll be getting the dimensions of pressure as ml minus 1 t minus 2. For volume, the dimensions are meter, unit is meter cube, so it will be L cube. Fine. For N is the number of moles. N is the number of moles. And what is the dimension for number of moles or amount of substance? It is mole itself. It is mole itself. Clear? And what is the dimension for temperature T? Temperature T, it is denoted by K, that is Kelvin. So you have P, dimensions of P, V, N and T. So go ahead and find out the dimensions of R. Go ahead and find out the dimensions of R. Please be quick. It's very simple, straight, clear. Easy as well. Chalo, quick, please. Okay. Sanika is with L2T minus 2K minus 1. Okay. Pressure, this mass M. Sanika, please check. Mass M is there or mass M is missing. You please check your part. Mass M is there or mass M is missing. Because the answer that you have given in this part, mass M is missing. Please check. See, mass M is missing in your term. Okay, chalo, I will start. P into V. So PV, P multiplied by V. So ml minus 1, T minus 2 multiplied by L3. So I get PV as M L2 T minus 2. This is what is P. P multiplied by V, ml2 T minus 2. Okay, T minus 2 divided by NT. So this is moles and this is K. So this goes into numerator. So what I am left with, I have M L2 T minus 2 mole minus 1 and K minus 1. This will give the dimensions of universal gas constants. Yes, most of you have given the right answer. Perfect. So I hope this part is understood to you people. So now you people, but remember better, while doing these questions are very simple. These questions are very simple, but you must know the initial formula. You must know the basic formulas, as well as you must know the basic units. Up till the time you don't know the basic units, you don't know the basic formulas, you would find difficulty. So you very well need to know the basic units and basic formulas. Okay, chalo. Let's go ahead with another type of a question. Let's do another type of a question. It is of a bit different kind. However, it doesn't involve different concepts. However, it doesn't involve very different concept. You just need to do with the same process. The process remains the same. Okay, no need to change a lot. Okay, chalo. Please write down if force if force, velocity and time are considered to be fundamental units, then find the dimensions of mass. Okay, I do this question for you to understand this type, then we'll go ahead on another type of a question and then you will do it. So the question says, if force, velocity and time are considered to be fundamental units. Then find the dimensions of mass. Now in this case, mass is not acting as a fundamental unit. In this case, mass is not at all acting as a fundamental unit, but mass is acting as a derived unit. Mass is acting as a derived unit. And velocity, force and time, they are acting as the fundamental unit. Okay? So I need to derive, or we need to derive the dimensions of mass. Okay. So let's go on to simple expression for force. So what is the expression for force? Force is mass into acceleration. Perfect. Force is mass into acceleration. I can break this and I can also write it as force is equals to mass multiplied by acceleration is velocity divided by time. Okay. So why I have taken acceleration as velocity? We know acceleration is rate of change of velocity by time. So why we broken this also? Only for the reason because the fundamental quantities are force, velocity and time. So we need to get it into the basic, any expression into basic fundamental quantities. And over here, the fundamental quantities are velocity and time. Fine. Okay. So what will be mass from here? Mass from here would be force into time divided by velocity. Perfect. Will be force multiplied by time divided by velocity. And these are fundamental units assumed in the question. So what will be the dimensions of mass? The dimensions of mass would be f, time, t, velocity, v, minus 1. So this will be dimensions of mass. And you see the dimensions of mass are in terms of force, velocity and time. So this is the dimension of mass with respect to the fundamental, in terms of fundamental quantities, force, velocity and time taken in the question. Please check, is this clear to you so that we move ahead with another question. Go ahead, go ahead. Is it clear to all of you? If it's clear, we'll move ahead to the applications of dimensional analysis. Please see if it is clear to you. Okay, chalo. Let's go ahead now with applications of dimensional analysis. And one of the very basic application of dimensional analysis is to find out the dimensions or unit of an unknown variable. Okay. So the first application that we are going to do is, the first application is to find the dimensions, to find the dimensions of unknown variable. To find the dimensions of unknown variable. Okay. Now we are going to play again with the concept that two quantities can only and only be added if they have the same unit or dimension. I repeat, two quantities can only and only be added or subtracted if they have the same units or dimensions. Fine. Or vice versa. That if two quantities have been added, that means they have the same unit and dimensions. That means they have the same unit and dimensions. Okay. So let's do a question for this part. If V is equals to U plus xt, if V is equals to U plus xt, where U is initial velocity, V is final velocity, and P is time. Find find the dimensions for x. You need to find the dimensions of x. I've taken a very easy example because you will be able to make out, sir, this is the first equation of motion, and x is nothing but acceleration. This is known. So with this question, first of all, assume that you don't know what is x. Okay, you find out the dimensions, you get to know x is acceleration. You assume that you don't know what is x. Okay, so let's find out. So v, which is meters per second, dimensions or unit of v, initial unit of v is meters per second, is equals, for you it is meters per second plus x multiplied by seconds. Okay, now this question has been given. Fine. You need to find the unit of x, the dimension of x. Okay? If you see x multiplied by time, I'll write to you only. Okay. X multiplied by time is added to meters per second. Is added to meters per second. It is already added. It is added to meters per second. If it is added to meters per second, that means the dimensions or the unit of xt, not alone x, the unit or dimension of xt is same as the unit or dimension meters per second, because this quantity is added to this quantity, and it can only be added if their units or dimensions are same. That means the units and dimensions of meters per second are the same as units or dimensions of xt. Fine. So let's equate their units. So therefore, unit of x multiplied by t is equals to meters per second. Fine. So now what I have x multiplied by unit of time is seconds is equals to meters per second. So therefore unit of x is meters per second square or meters second minus 2. Fine. So you got meters per second square. Thus we know that it is the unit of acceleration. Fine. So what will be the dimensions of x? The dimensions of x will be, there is no mass. So m is 0. You can take m to the power of 0 or you don't take. So here over here you will have L, length, time, path minus 2. Is it okay? Is it clear to all the students? Simple process. Okay. Let's do one more question. Okay, let's do one more question so that this is clear to you. Okay, so we will find out the dimensions of another variable, and let's find out the dimensions of A in the equation. The dimensions of A in the equation. You may take P. This we have already done actually. So let's take second equation of motion. S is equals to AT plus half dimensions of x xt plus half a t square. Okay, where s is the distance, t is the time, and a is the acceleration, and we need to find out the dimensions of x. We need to find out the dimensions of x. Chalo, go ahead. Find the dimensions of x. Quick. Please be quick. Find out dimensions of variable x. You just need to follow the basic principles that two quantities, if added, that means their units are same. Or if two quantities can only be added or subtracted if their units and dimensions are same. So please go ahead and find the dimensions of x in this question. Hurry up. Quick. Give me the answer. You must not take so much of time. This is a very simple question. See, over here again if we see, xt is added to 80 square. xt is added to 80 square. Okay, na? So one person has come up with the answer. Prakhar has come up. L minus 1, T minus 1. No, beta, not L minus 1, T minus 1. Yes, Ashutosh is correct. Okay, so xt is added to half 80 square. That means unit of xt should be equals to unit of 80 square. Unit of xt should be equals to unit of 80 square. Chalo. So unit of xt, what will be unit of xt? X, we don't know. Time is seconds. Unit of 80 square, A is meters per second square. Perfect. Multiplied by seconds का square, time square, second square. Okay. So unit of x will be meters per second or meters second inverse. So its dimensions will be meters, its length, seconds, its time, LT minus 1. LT minus 1. Is it clear to you? Yes, most of you got the right answer. LT minus 1. It's LT minus 1. Okay, chalo. We do last question, and this question is a good question. Let's see if you people are comfortable now in doing this question. Okay, find the dimensions of A by B from the equation. F is equals to A root of x plus bt square. F is equals to A root x plus bt square, where x is distance, and t is time. F is but of course force. Here you don't need to find out the dimension A or B, you need to find the dimension of A by B. Okay, see, process is going to remain the same. We are not going to see anything new. The process is going to remain the same. You find the dimensions of A divided by B. Chalo, hurry up. Please be quick. Find the dimensions of A divided by B. A divided by B. Of course, you need to find the dimensions of A first, then B. Quick. See, remember, now over here, the concept that we're going to use is that A root x is added to Bt square. Is added to Bt square. Okay. Let's just assume that unit of A root x is meters. Unit of A root x is meters. So what will be the unit of Bt square? Meters. It will be meters. So meters plus meters will again give you meters. Fine. Meters plus meters will again give you meters, which will be the dimension of force. Which will be the unit of force. So therefore, the unit of A root x is equal to unit of Bt square is equal to the unit of F, or dimension of A root x is equal to dimension of Bt square is equal to dimension of F. That means dimension of F is equal to dimension of A root x. Similarly, dimension of F is also equal to dimension of Bt square. So from this part one, you would be able to find out the dimensions of A by equating with dimensions of F. From second part, you would be able to find out dimension of B by equating it with dimension of F. Okay, you get A, you get B, you just divide A by B. You just divide dimensions of A by B and you get the answer. Is it clear? So this question, you may please solve it and we'll check the answers tomorrow. Okay, so that's it for today. You'll have your chemistry class at the usual time of your physics class. Okay, so thank you very much. Have a nice day. Enjoy your day. Take care. Bye-bye.